Okay, Chapter 10 starts with a review of functions, their operations and composition of functions. So here we have the basic operations here. If you added them, f of g, f plus g of x is equal to f of x plus g of x. F minus g of x is equal to f of x minus g of x. That's a minus in there. It's kind of hard to see. Let's see if I can zoom in a little bit. Focus a little bit. And f times g of x is equal to f of x times g of x. If we're dividing, f over g of x is f of x over g of x as long as the denominator is not 0. So that's our little review. Now we're going to have some examples here, so let me give you this example. If f of x equals x squared plus 1 and g of x equals 3x plus 5, they want me to find f plus g of 1. So what I need to do is evaluate f of 1, which is 1 squared plus 1, which is 2, g of 1, which is 3 times 1 plus 5, which ends up being 8. And then I just need to add those together. 2 plus 8 will be 10. So f plus g of 1 is 10. If you're subtracting, f minus g of negative 3, you would need f of negative 3, which is negative 3 squared plus 1. 9 plus 1 is 10. G of negative 3, which would be 3 times negative 3 plus 5, which is negative 9 plus 5, which is negative 4. And you would need to subtract those. 10 minus negative 4 is 14. If we have a problem where we are multiplying f of times g, fg of 5, our f equation is f of 5 equals 5 squared plus 1. G of 5 is equal to 3 times 5 plus 5. So we get 25 plus 1 is 26. We get 15 plus 5 is 20. We're multiplying those. So that is 26 times 20, which turns out to be 520. If we're dividing f over g of 10, then I'd need f of 10, which is 10 squared plus 1, g of 10, which is 3 times 10 plus 5. So this is 100 plus 1, which is 101, 30 plus 5, which is 35. So this would be 101 over 35. You're also asked about domains of certain functions in this section. And if I give you the function f of x equals 8x minus 9 and g of x equals the square root of 2x minus 1, and they ask you to find the following and give the domain. The domain means that all the values x can have. There are restrictions on the x values when you have a variable in the denominator or when you have a variable under the radical. We know that a denominator cannot be 0. We also know that under the radical, the smallest value it can be is 0, so it can't be negative. So there's really no restriction for f of x. It doesn't have either of those situations, so its domain is any number from negative infinity to positive infinity. However, I need to figure out what the domain of g of x is. The smallest amount that I can have under the radical is 0. So I set 2x minus 1 equals 0. I solved that equation. X is 1/2. That is the smallest value x can be, and this be 0. If it gets any lower than 1/2, that value up there would be lower than 0, which would be negative, and it wouldn't work. So we can use any number from 1/2 to positive infinity. And notice that I put a bracket around 1/2 because you can use that value, and I put a parenthesis around infinity. We always put parentheses around negative and positive infinity. Now what if we had a problem where we had 8x minus 9 over the square root of 2x minus 1 for my function, and I'm asked to find the domain? Well, in this situation, even though x can be 1/2 and make this 0, we can't let it be 1/2 because it's in the denominator. So even though it satisfies the radical part, since that radical is in the denominator, you're not going to be able to use 1/2. You're going to have to put a parenthesis around it and go all the way to infinity. So if you have a radical in the denominator, you have to make sure that you abide by the most restrictive rule, which would mean you would have to be from 1/2 forward. Now you're also going to see composite functions in this section. A composite function means that you're going to solve one function and use its answer in the other function. Let me give you an example. Let's say f of x is equal to 2x and g of x is equal to 3x squared plus 1. And we're asked to find f of g of 4. Okay, well, you're going to start with the innermost function, g of 4, and you're going to evaluate it for 4. So we're going to say g of 4 equals 3 times 4 squared plus 1. 4 squared is 16. 16 times 3 is 48, plus 1 is 49. So let me write that out. 3 times 16 plus 1 is 48, plus 1 is 49. So g of 4 is 49. So then I'm going to come back and I'm going to take that and use it in place of g of 4. So I'm actually finding f of 49. F of 49 would be 2 times 49, and that answer would be 98. So we've found the composition of those two functions. Okay. If f of x is 3 over x minus 1 and g of x is 2 over x, I want to find the domain of the composition of f of g. So it's find the domain of f of g of x, also written as f of g of x. Looks like bog, but the O is kind of bold, so it just represents composition. So to do that, we need to find the domain of the innermost function. The innermost function is the g function, so it's 2 over x. Well, that domain is all numbers except 0. You can have negative numbers in the denominator, you just can't have 0. So this domain is written as x not equal to 0. They may want you to include negative infinity all the way to 0 in union with 0 to infinity. Okay, they may want you to just say x is not equal to 0. They mean the same thing. Notice I put parentheses, not a bracket. So we find the domain of the inner function, then find the domain of the outer function. Now the outer function says x can't be 1. If x is 1, it would make that denominator equal 0. So that would be negative infinity all the way up to 1 in union with 1 to infinity. Now set the inner function equal to the exclusion of the outer function. So if the inner function, 2 over x, cannot equal 1. If it does, then it'll cause the whole thing to be invalid. So for that to happen, we would need to, what value of x would cause that to happen if x were 2? So we can't let x be 2. So the domain of this is x such that x cannot be 0 and x cannot be 2. That's how they want you to indicate the domain. You might need to write negative infinity all the way up to 0, in union with 0 to 2, in union with 2 to infinity. Why don't we indicate anything about the 1? Well, we found that restriction just so that we could make sure the second function didn't take that value. Now this will be the end of the video for 10.1, but tune back in for another video of 10.2.